Sri Gurubhyo Namaha children, welcome to our online teaching academy Ekalaiva. Today we are going to learn about magnetic effect of electric current of CBSE class 10 science. Now children, just tell me what is common to these things: an electric bell, maglev train, MRI scan and crane lifting the iron bars. What is very common to these things? Yeah, you are right. Electromagnetism is a common thing to all these things. So today we are going to learn about the magnetic effect of electric current. We know what is electricity and what is electric current. In our previous class we have learned about electric current. So what is electric current? Electric current is a flow of charge, rate of flow of charge. So in our previous lesson we have learned that electric current has heating effect. Same way it also has magnetic effect. How can we say that it has magnetic effect? We need some scientific proof, right? Yes. So when I keep the magnetic compass near a current carrying conductor, it started to deflect. This discovery was done by a great person, Hans Christian Ørsted. He is very famous person in the year of 19th century. And he played a crucial role in order to understand the concepts of electromagnetism. And in 1820s, he accidentally discovered this electromagnet, that is, current has the magnetic effect of electric current. Okay. And so his discovery played a very major role in the discoveries of radio, television and fiber optics. So now let's get started the lesson. So the very first thing, we need to know what is magnetic field. We all know what is magnet, right? And we should know what is magnetic field. A field which is surrounded by the magnet, or the magnetic force influenced by the any other object, we used to call it as magnetic field. Okay. A magnetic field is a region around the magnet where the other magnetic objects can influenced by it. Okay. So how can we say that a particular magnet has a magnetic field? So let me explain you. You need to take a white sheet and we have to place a bar magnet, and we are going to sprinkle the iron fillings, and after that you have to give a gentle tap, and once you have done, you can see that iron fillings will arrange themselves in such a manner. This is a region, this is only magnetic field. Then how can we define it? So let me give you the definition. The region surrounding the magnet in which the force of magnet can be detected is said to have magnetic field. So we know that if you take two different magnets, if you bring together, either they will repel or they will attract each other. Why is it so happening? And you can find that attraction or repulsion in a particular distance. So that distance we used to call it as magnetic field. So how can I plot a magnetic field around the magnet? So this is the one step. By using iron fillings we can find out the magnetic field around the magnet. And the other one, how can I plot the magnetic field lines around the magnet? So you need to take a white sheet and you have to place a bar magnet and you have to draw the boundaries and then you have to take a magnetic compass, and if you need to place the compass near the North Pole. So, near the North Pole you are going to place the magnetic compass, and magnetic compass is also a magnet, is a small magnet which is suspended over there. Okay. And we know that magnet will have a North Pole and as well as South Pole. So, even a magnetic compass will have North Pole and South Pole. Usually it is used to find out the direction. So, what happened when you bring this magnetic compass near the North Pole, it will get deflected, because we know very well that unlike poles will attract each other and like poles will repel each other. So that what will happen when you bring the near the North Pole, the magnetic compass will deflected, the South Pole will shows point at the North Pole and North Pole will goes up. Okay, and what you have to do is you have to mark the North Pole. Again you need to place the magnetic compass here and you need to mark the North Pole of that. Same way you have to repeat the steps till you reach the South Pole. So this step has to be repeated so many times, and after that you need to join all the dots, and once you have joined all the dots, the field will appear like this. So this is the region surrounded by the magnet where the attraction or repulsion force can be experienced. So we have seen two different types of finding out the magnetic field around the magnet. Now let me tell you how can we define the magnetic field lines. So magnetic field lines, they are a curve around a magnet. Curve around a magnet such that tangent at any point on the curve gives the direction of the magnetic field at that point. So if I draw a tangent over here, and it will give you the direction of the magnetic field. Now let us learn about the properties of magnetic field lines. The very first property of a magnetic field, they are always closed and continuous curves. They are closed and continuous. How can we say they are closed and continuous? So let me tell you, if you see the magnetic fields around a magnet, you can see that the magnetic field lines will emerge from North Pole and merge at South Pole. They will emerge from North Pole and merge at South Pole. This is the outside the magnet. What will happen inside the magnet? Inside the magnet, the field lines will from south to north. So they are closed and continuous. That is why we are stating that magnetic field lines are closed and continuous curves. Next property is the relative strength of the magnetic field is shown by the degree of closeness of the field lines. So if the field lines are very closed, you can find that in the poles, you can find the field lines are very close to each other. So this closeness indicates the strength of the magnetic field. So if the field lines are very closed, so it has a strong magnetic field over there. And you can see here, when you compare the poles and as well as this region, you can see the distance difference in the distances. So if you see in the poles, they are very closed, but if you see here, the space between two lines are more when compared to the poles. And here when you compare the poles and as well as this region, this has a weak magnetic field, and here it is the strong magnetic field. And the next one, the magnetic field lines, they are vector quantity. They have both magnitude and as well as the direction. The next property is no two field lines found to cross each other. They will not intersect at all. Suppose if they intersect, then if we keep a magnetic compass over there, and the magnetic compass should show the two different directions, which is not at all possible, because magnetic compass will show always the one direction. So the magnetic field lines will not cross each other, they will not intersect. That is what the tangent at any point shows the direction of magnetic field lines. So two different field lines is not at all possible. So that's all about the properties of magnetic field lines. Now we are going to, I am going to explain you about the Oersted experiment, the magnetic field due to a current carrying conductor. So for this, what I have to do is, we need to take a current carrying conductor which is connected with the battery, and as well as key. So once I have connected, I need to keep the magnetic compass over the current carrying conductor. So when I keep it, so after closing this key, the currents will started to flow through that. Before that, we need to notice the direction. So here the current wire is kept in the north-south direction. So the current is, according to this, the current is flowing from the north to south. So in this particular wire, let us take this wire alone. So in this wire, the current is flowing from north to south. So there is a magnetic compass. So when I close the key, the magnetic compass will deflect it towards the east side. The magnetic compass should have, before that it should have shown the north direction. So the north direction of the magnetic compass will be deflected towards the east side. In the next case, what I am going to do is, I am going to change the terminals of the battery so that I can reverse the direction of the current. So when I reverse the direction of the current, I am going to close the key, and now the current is going to flow from south to north. In this wire alone, the current is flowing from south to north. So the north pole of the magnetic compass will deflect it towards the west. So this is what Oersted found out. And how do we remember these directions? Okay, and there is a rule called Snow rule, SNOW. It is an abbreviation. S stands for south and N stands for north, O stands for over the needle, and W stands for west. So now let me tell you, when current flows from south to north. So you can see this picture, the current is flowing from south to north over the needle or over the magnetic compass. The north pole of the needle will deflect it towards the west. So that is the abbreviation, Snow rule. Okay. So that's all about the introduction. We'll see the remaining in our next class. Please do subscribe our channel to get the latest updates. Thank you, children.